In the diagram, O is the center of the circle. AB is tangent to the circle at A, and angle ADB is equal to 52 degrees. And here we have the diagram. Calculate the value of angle CAD. Okay, so first let us label this angle. Let us identify the angle that we're trying to find. And so let's highlight it. So we have C, we have A, and we have D. Okay, so we have to zero in on this particular triangle. Now which angle do they want? Well, they want the angle in the middle, angle A. And so let us highlight that. So the angle that we want to find is this angle right here. So that's the missing angle that we want to find. All right. And so how are we going to find this particular angle? Angle CAD. And so we're really looking for this particular angle, angle CAD. All right, so what do we know? Well, we know that this is 52 degrees. But what is angle C? Do we know what is the measure of angle C? Well, we can use this theorem. This theorem says that angles in a semicircle, I'm sorry, this theorem is headed as angles in a semicircle. So it's headed as angles in a semicircle, and it states that the angle in a semicircle is 90 degrees. And we even have a diagram. And based on this diagram, notice that AB is the diameter of this circle, and it separates the circle into two halves. So this semicircle right here, and then we have this semicircle right here. And so what we have here is this angle right here is in the semicircle, and this is angle C, and it measures 90 degrees. So the angle in a semicircle is 90 degrees. In a similar manner, we have diameter DA in this circle, and it separates the circle into two halves, this semicircle and also this semicircle. And this angle right here, this angle, the angle in the semicircle is 90 degrees. So this angle right here is 90 degrees. And so that means that angle C right here is 90 degrees based on this theorem, angles in a semicircle. And so that's 90 degrees. What do we also know? Well, we also know that angles in a triangle add up to 180 degrees. So we could add 52 and 90 and take that sum and subtract it away from 180. And so that's how we're going to get angle A. And so we have angle CAD is equal to 180 minus 90 plus 52. What is 90 plus 52? Well, 90 plus 52 is 142. So we have 180 minus 142. And 180 minus 142 is going to be 38 degrees. And so the answer for this one is 38 degrees. Next, we have to figure out what is the size or measure of angle CAB. So let's do that. CAB, angle CAB. So let's identify or highlight this angle, angle CAB. So what do we have, right? We have, here's the highlight, and let's use yellow. So we have angle, this is C, all right? This is A, right? And then this is B, okay? So we need to figure out, so which triangle we're looking at? We're looking at this triangle, all right? And which angle are we zeroing in on? Well, we're looking at angle A again, all right? But what we actually gonna do is we're actually looking at, let me highlight it. We're actually looking at this angle right here, this one, all right? So this angle is what we're looking at, right? Now, what do we know already? Well, we already know that this is 90 degrees, which we saw previously, all right? We know that's 90, and we already know that this angle right here is this angle right here. We saw it already, this angle is 38 degrees, okay? And so what we actually need is to figure out the size or the measure of this angle right here. Now, in order to do this, we're going to use the theorem. This theorem is called the alternate segment theorem, and it states the following. The angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. And so if you look at the diagram, we have theta. So AC is the chord, all right? And this black line is the tangent. And theta is the angle that lies between the chord and the tangent. And so what this theorem says is that the same angle theta that lies between the chord and the tangent is going to be equal to this angle that is subtended by the very same chord. And so that's what this theorem states. Now, if we go on this diagram, we see this tangent. So this is a tangent line right here. And we see the chord AC. And then we see our angle A is the angle that lies between the tangent and the chord. And based on this theorem, we know that this angle is going to be equal to this angle that is subtended by the same chord, all right? And we know that this angle is subtended by the same chord because if you look carefully, right? Let me change the color. We know that 52 is subtended by the same chord because the legs of this angle rests on or lies on this chord. And so that means that angle D, or the angle that measures 52 degrees, is subtended by the same chord. And so that means that since this is 52 degrees, that means that this angle right here is also 52 degrees. And so that means that angle CAB is equal to 52 degrees because of the alternate segment theorem. Next, we need to figure out the size or the measure of angle CBA. Angle CBA, so let's erase this. So let's highlight angle CBA, all right? So we have C, B, and A, angle CBA, angle CBA. So let's do this. So we have, with looking at this particular triangle, okay, and what do we have, right? Well, first of all, what do we know? Well, we know that this is 90. We saw that previously, so we know that this is 90 degrees. We also know that this right here is 38 degrees. We also know that this right here, this angle right here is 52 degrees based on the alternate segment theorem. And what we also know is that if this is 90, right? If this is 90 and angles on a straight line add up to 180, that means that this must also be 90 as well, because 90 plus 90 is 180 degrees. And so what do we have, right? We have 90, and our goal is to figure out what is the size or what is the measure of angle B, right? This same angle right there. That's our goal, to figure out what is this size or what is the value of that. Well, what we have to do is we know that angles in a triangle add up to 180 degrees. And so that means that we're going to add 90 and 52. And then we're going to take that sum and subtract it from 180. And so that's how we're going to get angle B. So we have 180 minus 52 and 90. Add that. When we add it, we get 142. So we have 180 minus, remember, 52 plus 90 is 142. So we have 180 minus 142, and that gives us 38 degrees. And so that means that angle B here is 38 degrees. And that's the answer to this question.